Hello everyone, in this video we are going to create a script for the camera to follow our player in a third-person view, which we will be use in the third-person controller in the upcoming videos. Alright, first I'm going to add a simple cube. I will also move the camera a little bit closer and just reset this Y value. And if your lighting is like this, you can go to the lighting section and generate lighting, and it will be the lighting will be baked. So what I'm going to do, actually, let's deconstruct what we want to achieve here. We basically, to orbit around an object, first this camera needs to rotate, based on mouse movements, right? If we want to rotate it horizontally, we'll have to rotate it around the y-axis. But if we want to, rotate vertically, then we need to rotate around this x-axis. So let's first just create a simple material for this cube to see it better. Alright, now let's create a script inside this scripts folder, and we're going to name it just move around object. Let's open up this script. Now what we need is to get the mouse input. Let's get the mouse X. We're going to use the input library from Unity, and its name is mouse X. And let's multiply this with a sensitivity value. And we can just write it here: input float, private variable float, mouse sensitivity. And we can make it editable from the inspector, so therefore we can make it serialized field. And let's just add it to the mouse sensitivity. And for the member variables, you can, this is a naming convention, you don't have to use this, but for the member variables, which resides inside the class and not within any method or function, for distinguishment, you can just name it like this. Let's debug this value. Let's see what we'll get from this mouse X, and save it and return to Unity. We'll also need to attach this script to our camera, and you can just drag and drop or add component and input this value. Alright, let's open up the console and hit play. And also, you don't need to maximize. So, as you see, we don't get anything from this. This is because mouse sensitivity doesn't have a initial value. So let's just give a value for 3.0, and now we still don't get, because this script is not resetted from this inspector. But now, as you can see, we'll have the values as we move around our mouse X. We'll get these values. So we will use this value to rotate our player around y-axis, because as we move our mouse at the x-axis, we basically want to rotate horizontally. So to do that, we'll have to change this y rotation. All right, now let's see here how we'll achieve this. So basically, this rotation value in the script goes as Euler angles, which resides in the transform property of the game object that this script is attached to. So there's this local Euler angles, and this local here means there is also an Euler angles value. The main difference is one of them is based on the local axis, and another one is based on the world axis. So basically, when it changed an object's rotation, as you can see, these axes also move, and you can visualize this by just toggling this global and local. If you keep it as global, you'll see that the axis won't change because the world space does not change, but the local space changes. So to see the local change, you can just toggle from here. I'm just gonna keep it at local to see the axis change. So we're going to assign a local Euler angles here, and to do that, we are going to assign a rotation value here. So let's to demonstrate it, let's give 0 for the x, and for the y, I'm going to just give it a 5 value to just see what this will do. All right, let's play this and also reset this position. Now, as you can see, the y rotation is 5. Yeah, it is the value that I put here. All right, now what I want is I want to change this value with mouse X, but this won't be enough to properly rotate the object, as you see, because when I change the rotation, it applies it only once and then it resets, because we're not incrementing it. We're just passing a value just once and not iterating. So it's not going like this. It's just like that. We're just giving 5, and then we're giving 2, and then 4. We're not iterating. We're just passing a value once, and it changes frequently as we move our mouse in the X direction. So for that, we are going to keep our rotation y value. We are going to store it in a member variable, and whenever we rotate, we move in the X direction, we're just going to add it to the rotation y, and we're going to pass this rotation y to the as a rotation value. And now if we press play, now as you can see, now our rotation is incrementing based on the values we provided. So let's also do the mouse y. and we'll pass this to the rotation. Let's test this. And now, as you can see, we can rotate around X, and we can rotate around Y. Now, as you can see, there is a unwanted behavior here. I mean, our game object can rotate freely around itself at the X axis. To solve this issue, if you find it as an issue, like in the third-person controller, it's not something you see. You usually clamp this rotation, and there is a utility in the matf library called clamp. This will get, as you can see in here, this will get a value and a minimum and a max value. So in here, our value is rotation X, and you can just give for now a hard-coded value here, minus 40 and 40. And if we go to the Unity, now as you can see, we clamped our X rotation in negative 40 and 40 values. Also, we can rotate around Y, 360 degrees. So now we can rotate properly. And next step is to look at a game object while we return, while the game object rotates. All right. Now the information about the local axis change will be important here. So as you can see, whenever our game object rotates, its local axis changes. And we will use this information to fix our, orbit our camera around the game object, around the target, actually. And specifically, we're going to use this blue color axis, which is the Z axis, and which in this script called as forward vector. So in here, we are going to set our game object's position to, we're going to store a target, a transform value from a target, which will get it from the inspector. So therefore, I'm making it serialized field. And we'll need its position vector. And we're going to subtract our game object's forward vector. So you'll see what this do. Let's save it and return to Unity. And now, as you can see, there's a target value. Let's drag this cube and assign it to the target as a target. Now when I play this, you'll see I'm rotating around an object, but you see I'm very near it. There isn't any distance from the game object I'm rotating around. So for that, let's also create a serialized field, a float value, and let's give this distance, and let's give a default value of 3. And now we are going to multiply this forward vector with this distance value. Now save it and return to Unity. And now, as you can see, I can rotate around this game object and with applied distance. Now notice this forward vector always points to the game object, This is because we are subtracting forward vector from the target's position vector. Therefore, we get this vector in the middle. So, all right, we can move around a game object, and we can also add a smoothing, and that is achieved by a smooth damp function. You can see it in the documentation, Unity vector free smooth damp. In this documentation, there is this example here. Now we're going to use this functionality. So to do that, we're going to store our next rotation. The next rotation will be this value, basically. We are going to store this as next rotation. And also, you can remove this 0 value, because there is an overloaded function at the vector free, which, as you can see, creates a new vector with given x and y components and sets z to 0. So if you have two values for x and y, you can leave blank for the z-axis, because it will be set to 0 by default. And we're going to store a current rotation, which will be a vector free. And in here, as you can see in the smooth damp method, we are going to have a first value, an initial value, and a target value. As you can see, current value and a target value. So current value will be what? The current rotation. And the next target value will be what? It will be next rotation. And as you can see, there's two arguments we need to pass here also. One of them is current velocity, and this will be a variable that for this smooth damp function to store a velocity value, which is only needed for the smooth damp function. As you can see here, we're going to create camera velocity, or just smooth velocity, and we'll initialize it with vector free, a 0 vector basically. Also, we'll need a smoothing factor, smooth time, and we can just say default value of 3 here. We also want this value to be serializable, so that we can change it in the inspector. And as you can see in the documentation of this function, this will be a reference value, so we'll need to add a ref keyword at the start, and then we're going to write the variable name, and then we're going to assign our smooth time value. And rather than giving the vector free for the Euler angles, we're going to give the current rotation. Now let's save this script and return to Unity. We can see the smooth time in the inspector, and now we can see there is a all right, this is actually very slow. Let's like this smooth time 0.2, and this for whatever reason this script in the inspector won't be resetted. I think this is the expected behavior, I guess, so you'll need to reset it here too. And now, as you can see, we have a smooth third-person camera. We can orbit around an object. So in the next couple of videos, we're going to use this script for our third-person player. So see you in the next videos.